Good evening and welcome back. Hope everybody's having a good night so far. I'm hoping to have a good one from here. I don't know if this will be a long stream, but, looking for some good distractions. I made the possible mistake of looking up some more information about the current goings on around the globe right now, and, I'd rather think about something different tonight. So let's fly some spaceships instead. I did already start up the game and test and make sure the script loading is working, so that shouldn't be a problem this time. We should actually be able to pick up right where I left off last stream. Where I left off Space Engineers last stream, obviously. I continued playing some Magic afterwards, but I had to cut the space short. Um, and anyway, if you don't know what was going on last stream necessarily, currently working on a project in Space Engineers I'm calling Sentinel, which is my attempt to use AI in the game via the in-game programmable blocks scripts. Um, Teaching my ships to fly with an autopilot right now that's hopefully going to be developed to be better than the game's own built-in autopilot, and eventually expanding that to all kinds of potential nonsense. I'm very much looking forward to it. Very excited about this project personally, um, and yeah, I want to share it with other people. So that's why I'm streaming it. But yeah, without further ado, let's dig in. Um, yeah, and right, I got what I think is a reasonable script written, with the newly added capability of getting the ship to hit the brakes so that it comes to a stop at the target destination instead of simply trying to reach a point in space without caring how fast it's going. Because, I want the ship to be able to stop. So we should be able to browse scripts today. Shouldn't have to hit refresh because this was deployed so long ago. We're going to go ahead and import the newest version of my A-Star ship script. And I wanted to check... Oh, perfect. I couldn't remember what my goal was set to right now. But I'm fine with this. This is setting our goal to 16 meters forward from the ship's, wherever the ship starts out. And no change in its up, down, or left, right positioning. So I know for certain that its route should be easy. It just has to go forward, so it should just fire the rear thruster to speed up, and then now, with the new added code, it should then want to fire its forward thrusters to slow back down to reach its target. Assuming this works, I'll add in other changes so that we can see how it handles, multiple axes. But for initial tests, it's kind of nice to keep it limited to just one. And by defining it relatively instead of just choosing a point in space, I can ensure that the goal is actually on the same axis as the ship, in case it ends up in slightly different positions after it's finished being constructed by the auto welder. But yeah, should work just fine. This should be the same. Yeah, this is our new code. So yeah, great. It's loaded into the programmable block of our template ship. I'm going to copy the template ship, replace the A-Star ship blueprint with what I copied to the clipboard, and then I can get the projector block, which is the one off in the distance there. Get the projector block and update its blueprints to this new A-Star ship blueprint. And then see what it does. press the button. And I'm going to go out and just watch it the first time. There's a good chance it gets constructed and then proceeds to come. We'll see. So, gets built. The welder arm retracts, so it's nice and out of the way, and then as soon as that's done retracting, a command is supposed to be sent to the ship to tell it to do its thing, and since it has not moved, I know that didn't work. But that's not entirely a surprise. Unfortunately, if I just look at it right now... Oh, it's thinking. Oh, I did get some logs. Alright. Alright. Well, that's something. So it's currently still trying to find a route to its goal. Yeah, and it shouldn't take anywhere near this long. So clearly something's a little off. I'm probably gonna have to do a little step-by-step debugging. I did some of this in the past before I was ready to bring this up on stream. I was hoping, I mean, I knew it was kind of inevitable that I'd have to do some of it again, but I was hoping it might not be this soon. I'm not sure there's really any benefit in me waiting this out. Seems like, I mean, yeah, it seems like it's simply not gonna work as expected. That's fine. I guess I can let it go and just see what happens, and start altering my code a little bit so that I can do some of the debugging afterwards. So I'm gonna switch to this view. Perfect. Still see Space Engineers in the background if we want to, but I'll make Visual Studio the key, the center. So what I want to do, I want to do a couple things to make this a little bit easier to debug. Currently the way the script is set up, here we go, this is, yeah, this is our, not that. Oh, this is, yeah, there we go, that's where. So the way this is set up is that when the command is first sent to the ship to begin plotting its route, as I have so eloquently named this method, it's called somewhere up here, yeah. When plot is a task it's given, which is something the brain knows to send it. Yeah, it'll set up its start state, and goal state, and everything else. It'll create the A-star class, which is where our algorithm lives, and it'll save it in this state machine variable. And the weird way that this method is set up, where it returns an enumerator, and we can do this yield return. I mentioned this briefly in the last one, but basically it allows us to kind of pause the execution here. And so this will return out, and then it says to setting the update frequency to once means it instructs this programmable block to run one more time on the next game tick. And then when it does, we will actually be doing the running the method continue plotting route, because I'm checking to see if the update type is once. That's kind of my override to say, hey, we're doing this, not that. And then we go here, we go back into the state machine. That move next basically tells it to resume where we last did a yield return, and then it'll keep going until it hits a yield return again. and it'll pause once again, and basically repeats that over and over until it finishes. And that's what's happening in game right now. Is the text in the window here only updates every game tick. Um, so these are logs from one game tick, and then it excuse me, resumes on the next one and does it again, spits the logs out again. They're continuing to move by very quick pace. We're not even seeing them all because the game ticks 60 times a second, and visually we're not seeing 60 updates a second here, but it's doing the best it can. But I want to slow that down so that we can see what it's doing step by step. There is a program that can be used to actually step into the code itself rather than just using the logs in game. But honestly, it's really finicky and it's a pain to set up. So if I can figure out what I need to figure out just by using the logs in game, I'm going to do that. If I feel like I'm missing something, then I'll try the other tool. But I messed around with it, and it's just, and maybe I haven't found all the optimal ways to use it yet, but it's not been easy. Anyway, so that's what it does right now. So what we want to do, and I set up something a little bit different. I had, oh no, I already have that as part of this. So I have this mid-process variable that defaults to false. Am I setting it anywhere right now? I might have gotten rid of those commands when I changed this a bit, which is fine. Setting it to false there at the end. That's fine. Okay. Oh no, there it is. The process is true. Oh, that's what I did. I just don't. Yeah. No, that's perfect. Right. So what I want to avoid now, though, is I'm not going to set this update frequency to once, because I am not wanting the program to automatically continue. I want it to continue to the next step when I tell it to. I'll provide an argument to the programmable block and tell it to run there, and it'll step through one by one. And that way I can control how fast it's going and actually get an opportunity to look at the logs. So we are, hold on, set in process. I didn't set it here. Let's set it here. In process equals true. So we're not going to set this. Is this the only other place it gets set? Seems like it would be. Yeah. We're going to comment that out so it does not. So this way it won't automatically trigger again. Oh right, I don't have to send an argument at all because I have the mid-process thing. Yeah, no, that's fine. That should work. That should work as intended. Okay, I think that's all I need to do on this part of the program. The other thing I want to do is, right now, we're processing as many nodes as we think we can before we yield return to let it go through the next tick. But again, for the sake of watching closely what's happening, I want to always process just one at a time. So I'm going to add to this if statement or true. So right now, so originally it was evaluating, it's like, hey, if the number of commands we think we might use on the next run is greater than the number of commands we have left, which is the number of commands that are allowed maximum in one tick, minus the number we've gone through so far. If we think we might use more than we have left, then we want to yield so that we can not crash the script. Because if we go overboard, the script stops and it won't start up again without manual intervention. And that sucks. So now we'll check for that, but also we just say or true. So this always evaluates to true. We always yield return. We will only ever process one node at a time. And hey, thanks Captain Edict for following along. Nice to see you tonight. Hope you, I don't know, hope this is fun to watch. I think it's super exciting. I mean, what's happening now may not be super exciting, but what I'm trying to do is. Yeah, anyway, I think that's all I need to change. So let's go ahead and deploy this script. All the changes were just in the A-star script, A-star ship script. I'm gonna go ahead back to the game and delete this ship because it's not doing anything productive. We're gonna go back to our template ship. Actually, I guess I could have just left that ship out there. I could just reuse that ship rather than rebuilding a new one. Oh, well, I'll do that next time. Browse scripts. I do want to make sure I refresh this time, otherwise this script might be the old one and not the new one. Should be the new one now. Go through our copy, update the blueprint with the new one. Yeah, because I won't have to go through all this if I just update that ship script directly. That's what I should be doing. Projector, blueprints, use this. And go. So it'll build a ship for us, same thing as before. Once it builds and the bar starts retracting, I'm going to go ahead and get in here. Because once that bar is retracted all the way, we'll get a command from the brain telling it to start. We should get some logs here. So yeah, so we replied. The ship is registered with the brain, so it knows what it is. It knows what commands to send. That doesn't super matter, but it's fine. And then it should have just oh no, it didn't get it right. It didn't get the command because the brain I needed to recompile the brain script because it didn't know that the other ship was stalled out. It's still waiting on a reply from the ship that was just running. That's what I did differently before. Okay. Let me check this. Oh, I didn't swap my views, did I? Well, it's okay. I'm back in Visual Studio again. I'll swap to views before I go back to Space Engineers again. I can send a command. I can just send the plot command, right? Yeah, that should work. Oh, here, let me flip these. Arguments. Plot. Run. Cool. That seems good. So we logged out our starting position and our goal position, which the Y and the Z coordinates don't change much. It's mostly that X coordinate changing by approximately 16 meters, which is what we expect. And now should be, because we're checking if mid-process is true first, it shouldn't matter what argument I enter. We should continue with our A-star algorithm. So let's see if that works. Run. Good. So we're currently at the top of the heap, and right now the heap is, well, we're always at the top of the heap. That's what that's always going to say. It's logging out the node that's on the top of the heap, which is the node that's the most promising. And right now, the node that's the most promising is the only one that exists. It is the starting position. And so this says its heuristic score is 7.2. So we're estimating that it takes 7.2 seconds to go from where the ship is now to 16 meters ahead of it by accelerating for 8 seconds and then decelerating for 8 seconds, because I know it's going from 0 to 0. It should be even. And we're estimating that it'll take 132 thruster activations. That sounds about right. 7 seconds. That seems a little high, actually, doesn't it? 7 seconds. 6 thruster activations per second. Yeah, where did we get 132? That seems like a lot. That seems like a lot. And this is a good place to start, is seeing if this makes sense. So I think I might add in some extra logging here in the heuristic calculation, at least temporarily. I don't know if I necessarily want it spitting out a whole bunch of logs every time we hit it, but at least to kind of get this initial evaluation. Okay, I'm pretty confident in all of the basic thruster calculations. State. Oh, this. Wow, I'm looking at the wrong method. Looking at my neighbor's method. Here's our heuristic method. There we go. There we go. That's more familiar. Yeah, right. This is thrusters, axes. That's fine. I wonder. Yeah, I wonder if it's 132. Oh, 132. So I said 7 seconds, 6 thruster activations a second, right? 6 going backwards, 6 going forward. Is about 42 activations, plus a little more because it's 7.2 seconds. 132 is a little more than 42 times 3, meaning we probably calculated that, yeah, we probably calculated that our right and left and up and down thrusters were going to be activating when in fact they're not. That would do it. That would get us to 132 for sure. So I need to find out why. This should be relatively easy to figure out just by going through. I shouldn't need to add in extra logging statements. I should be able to logic this out. So we go through an axis. So we're gonna pretend now that we're looking at an axis on which we should already be at the goal. Or close enough. Maybe that's a check I just need to add in. Is that, hey, if you're already within whatever distance of the goal, call it good. But yeah, let's see what it's doing. So count. This is the number of thrusters on this axis. This is greater than 0. That's correct. So one of the goal direction. It's either forward or backward, or sorry, not forward or backward. Let's say it's either left or right. Say we're on our left-right axis. So this shows up as one of the thrusters, world matrix backward, is either left or right because it's one of the left or right thrusters. That's fine. The goal unit vector dotted with our axis goal direction. The goal unit vector is the vector to our actual goal. Yeah. Oh, well, this is just negative. It should be, so goal direction, yeah. The goal unit vector dotted with the goal direction should be roughly 0. Or it should be exactly 0, but it might not be. Projected axis goal. If we project the goal vector onto our axis goal, this, again, should be 0. It may not be. Or not 0, but the current position. The ship's current position. Oh, or is it just 0? Oh, did I do something dumb with my map? Hold on. Project the goal vector, which is pointing straight ahead of the ship, onto the axis goal direction. Project projected axis goal. Goal vector. Goal vector. This is where I fucked up. The distance to the goal is just the projected axis goal length. The current position was already factored into creating this, because the goal vector was already determined from the goal position minus the current position. Yeah. This is just wrong. This should be the distance to goal on this current axis should be the length of the goal vector projected onto this axis. That was just written wrong. Cool. No, that's good. So now this should be 0. So this wasn't 0 in the code that got put out there, which is why it's all screwy. But now it's 0. So let's keep walking through and make sure nothing's still wonky. Excuse me. Cool. So we project current velocity onto the axis. That makes sense. I mean, that's going to be 0 as well, because our current velocity is 0. So speed is 0, this is 0. The goal velocity we know is also 0, because I know that's the goal we input. Great. So if, but this basically just does a bunch of calculations on the thrust, the potential of the thrusters, which is going to be the same regardless of the actual situation we're in, the actual state. So the distance it takes to ramp up to max speed and break back down to our target is definitely going to be greater than 0. So we won't be doing this calculation, we'll be doing the second. Get swap point velocity when total distance is 0. Does that make the math terrible? It should make the math easy. Zero minus something plus something reverse minus forward. Huh. I don't know what that's going to come out to be. It's not going to be 0. And I kind of think it should. Oh wait, no, it will. Oh right, it will, because total distance is 0. Final velocity is 0. Initial velocity is 0. All of these are 0, so it doesn't matter what's down there. Yeah. Right. No, yeah, that does return 0. Easy. Swap point speed is 0. Time to get between these, 0.0 over 0 minus 0 over something. And again, position is initial position plus 0 plus 0 time. Yeah, there's just going to be a whole bunch of zeros. This is going to return initial position, getting position delta V. I don't do a position delta V here. That's fine. So yeah, 0, 0, 0, 0. The steps are also going to be 0. Great, that should work. Deploy script. I mean, I probably missed something, but theoretically, that should work. Okay, so now, rather than doing what I did last time, oh man, I was showing Visual Studio on the tiny screen again. Oh man, I gotta get better about that. I apologize if that was almost impossible to track what I was what I was doing. I also could, yeah, I need to get that third monitor so I can have Twitch Studio up where it's not in front of one of my screens and I can see what's going on. Yeah, rather than doing the whole deleting this ship and making a new one, I don't need to do that. I can just update this script directly, refresh, go, and run. This is our first one. Run. Here we go. Okay. That's a very different heuristic. Oh, yeah, no, it would be. Because... yeah, because we took out that whole thing where our distance to goal was completely wrong. Cool. I legitimately don't know if 3.4 seconds is a realistic amount of time. I guess I could test that. That seems reasonable though. 16 meters is not that far. Ooh, you know what I should do? I should put waypoints in space that are, yeah, so I can get a visual idea of that. You know, that's an excellent idea that I should have done forever ago. Yeah, I'll just make some notes here. Hold on, let's recompile this. Here we go, perfect. Origin and goal. I'm typing this in, excuse me, in OneNote in my other screen just so I can track it. Negative 2.8009, negative 5.0359, negative 70.9248. That's probably enough precision. Goal is, there we go, negative 18.7958, negative 4.63322, and negative 70.9586. Great. I don't know what the shortcut is to pull up the GPS menu right away. Let's create a new coordinate. We're going to call it prox origin. Those coordinates are going to be negative 2.8009. That's not what that says. 2.8009. Negative 5.0359. Negative 70.9248. Perfect. Yeah, show on HUD. Great. New. Call this prox goal 16 meters. And we'll make that negative 18.7958. Negative 4.63322. Negative 70.9586. HUD. Perfect. Okay. So, yeah, this is our start location, obviously, and this is our goal location. So, yeah, that's not far. I think it's reasonable to think the ship can get there in 3.4 seconds. That doesn't seem unreasonable. 3.4 seconds seems doable. And 26 thruster activations. So 3.4 times 6, 8, 3.4 times 6, yeah, is less than 26, but it's pretty close. So I think I accept that. Oh, it would be rounded a bit because we did a ceiling on these. Oops, sorry about that. Yeah, that still feels a little far off, because like 4 seconds at 6 activations per second is 24. You know, it feels a little off, but it feels close enough to where I want to see what happens. Yeah, willing to see where it goes. I can go back later and work out the finer details. I'm curious to see what this does. So from here, we have the one node on the heap. It's just our starting node. We go to our next step. We have, yeah, there's some extra logging in here. Just extra stuff so I could kind of see where it was at every time. I wanted to be able to have reference to our origin position and our goal position at the start of every round, just so they were there for easy reference. The current instruction count is the number of commands that have been executed by the script so far. So only 5 makes sense. Like, this is just after we got back into our yield true. So there's plenty of space. It's not really going to be relevant for this particular test. So the first node we evaluate is our starting node, because it's the only one there. And then this is going through and evaluating each combination of thrusters to create a new state. So this is saying if we issue the command to fire just ion thrusters 3, which I should probably, I thought I had renamed these at one point so that I knew which ones were which. But presumably based on the score, because this is a nearly identical score to our starting position, this should be our rear thrusters that are pushing us forward. And that sounds familiar. I think 3 is right. So this is, if we fire just our rear thrusters, it moves us in the direction of the goal. And it's basically what we predicted our best possible outcome was from the start. So that's good. And it is in fact a slightly higher score, which is also good. It should be, if anything, higher. 2, I think, pushes us to the side. Because I think 5 are the forward thruster, are the thrusters on the front of the ship that would move it backwards. So I think 5 is what's going to make it the worst. I believe 2, 4, 6, and 7 are right, left, up, and down in some order. So they'll essentially push us out to the side, meaning it's worse, but not as worse, as much worse as 5. Yeah. If we go both 2 and 3, moving us forward, but also to the side, the time it takes is actually the same, or nearly so, which makes sense. Damn, this is actually showing it as slightly better, which is odd. It does correctly account for the fact that the number of thruster activations would be higher, because we're going to have to activate, not only did we activate an additional thruster moving us off to the side, but we're going to have to activate one to push us back in as well. Actually, we're going to have to do more than one. Something's a little off. Yeah, something's a little off. 4, 3, 5. Yeah, activating 5 is a much worse score, because that's pushing us in the wrong direction. Yeah, I should change the names of these. Okay. Alright. This was enlightening, but I do want to tweak. I do want to tweak some things, and I want to look a little bit closer at our thruster activation count calculations. So I'm going to swap back to Visual Studio main. We are currently with such a short distance to travel. We are never ever going to be evaluating this first block where the ship's going to reach max speed before it has to start braking. So all of our calculations that we're going to worry about at the moment are in this one. So for simplicity's sake, let's see. I want to first... I want to... print out which axis we're evaluating, because that would be relevant to know. And to do that, I can do what is it? It's program.echo axis plus axis 0 orientation forward. So that's going to display in the base 6 using the base 6 directions, which are forward, backward, left, right, up, down. It will print out the quote-unquote forward direction of whatever the first thruster that happens to be on this axis is. So it'll tell us if it was, because the forward direction of the thruster is the direction that the thrust fires in, the opposite direction in which it would move the ship. So yeah, if it's left or right, we know we're on left-right axis. Up down, we know we're on that somewhere. If it's one of the up or down, we're on that axis. If it's either forward or backwards, we're on that axis. Okay, so that'll tell us which one we're looking at. Yeah, let's have it print the distance to goal. That seems relevant to know. Goal. The velocity vectors, I don't care about right this moment. Okay. I'm gonna look at those. Those all seem fine. Alright. I don't really need to know the swap point speed, but I'm curious about I guess I would like to confirm the start and the first and second times on either side of the swap. That I would like to know. So, program echo start to swap time plus time for start to swap. That seems good. Echo swap to goal time swap to end. And I can add those together. Well, actually, the time cost is going to be printed out elsewhere anyway, so I'll be able to see that. Next time, right? Yeah, we'll get that, and then yeah, and then I guess I'll have it print these out, because this is what's confusing me, is why the steps, why the thruster counts are so high. So steps, accelerating, and steps, braking, and I know that gas.count and brake.count should always be 1, because there is, on this test ship, exactly 1 thruster in every direction. But for posterity's sake, for my own sanity, I guess, really, yeah, the total thruster activation count, since that's going to be summed up over each axis, I really just want to know what it is on this particular axis. So I'll just do that calculation again real quick. That's fine. And then again, we'll see the total later. So again, we can verify that I'm not totally screwing something up. There. Yeah, I think this is going to be useful. All right, deploy that. While that's deploying, which will not take long. This time I actually am going to delete this ship again, mostly because I want to go into the template and rename my thrusters. So, ion thruster 2. That's the one on the bottom. You can see the thrust coming out of the bottom thruster. So we're going to name this thrust down. Ion thrusters 3. This should be the one at the rear. Perfect. That's what we figured out based on that being the best result. Name this thrust back. 4. It looks like it's on top. I can see a slight glow. I can just jump out of this. Yeah. I didn't quite get my screen centered so that I could see them all. But yeah, it's the one on top. So, thrust up. 5. Thrust front. 6. That's the right. Thrust right. And 7 should be on the left. Yeah. Thrust left. So, I capitalized all of the rest. I should have capitalized that one. So I have named them for the direction that the thrust is pointed in. Again, the opposite direction that it's going to move the ship. But I think that matches up better with how it's managed internally, so that's fine. So yeah, that's the main thing. I wanted to rename those so that they'd be more clear when we were looking at the logs. But since we're here, might as well import the new code. And go ahead and do the whole replace again. Also going to recompile this script. I guess I didn't really have to. Probably best that I did. Have the projector refresh its blueprints. And yeah, there we go. Build us a new ship. Should have the thrusters renamed, should have the latest code. And it should actually get its commands from the... It's possible it will actually do some... Oh wait, no, it won't do anything. Plotting course, unidentified unicast message tag plot data. Excuse me? What do you mean unidentified unicast message? should have... Oop, not that. Here. Again, I'm gonna try to swap you back so you can see what I'm looking at. Should be getting here. Message tag plot. Unidentified unicast message. Message tag to string. Message tag to string. We already have a check for it to equal plot. Did I screw up? Hold on. What's the code look like? Plot. Ah. You know what? Just do it myself. Figure that out another day. That's fine. I went back into Space Invaders. Where did I put Studio? Yeah, I really need to get a third monitor if I'm going to do this. Alright. So, have our origin, our goal. Great. Run. Okay, this is part of the this is the heuristic evaluation of our starting state. Where the ship is right now. The distance to goal is almost 16. Alright, sure. This says that it should take us 1.7 seconds to reach our swap point and 1.7 seconds to go from our swap point to the goal. 11 steps accelerating and 11 braking. Total thrusters 22. 6 thrusters per second. 6 activations per second. You're saying it takes 5 on the second. That does probably work out correctly if you round up. I guess I have a calculator on the computer. Literally sitting in a computer. 1.7 divided by 6 divided by 6. That's not what I wanted to divide it by. What did I want to do? What is the math I'm doing? Why isn't my brain working? Steps is calculated by the time divided by time step. Right. Time step is 1/6 of a second, right? Because the time step is the tick time, which is 1/60th times the time step cost, which is 10, which is 1/6 of a second. So time times 6, right? Times 6, not divided by 6. That makes perfect sense. 1.7 times 6 is 10.2. Yeah, rounded up is 11. Okay, sure. So yeah, it's an overestimate. It's an overestimate. It's not supposed to be. I'm probably supposed to floor that. I really wanted to ceiling it because I think it's a more accurate description, but for the sake of the algorithm, I think I have to underestimate it. This is just a tiebreaker, so it's not always going to come up, but oh no. Oh, my daughter's crying. She'll probably go right back to sleep. Usually doesn't last long. And yeah, well, we'll see. Yeah, she seems pretty out of it. She's probably got her teeth coming in. Might have bugged her a little bit, but I suspect she shouldn't be up for long. Okay, let's see how the rest of this worked out. All right, so that's 11. That's fine. I may have to change that, but that's fine. Total thrusters so far 22. Sure. Yeah, this is on our forward-backward axis. On our up and down axis, the distance to the goal is very, very, very tiny. Start to swap time, very tiny. Goal. Oh, that's where our extra ones came in. That's where our extra ones came in. Because we're rounding up. Yeah, there's another reason to round down. Alright, so because we're rounding up, even though it takes, what is this, 6/10,000ths of a second to reach our goal destination, because I guess the ship drifted. I don't know why it's not 0. I guess it's floating point math, that's why it's not 0. Rounding error. Anyway, but because we're using the ceiling, it's gonna round up to 1, and then we add 2 thrusters and do the same in the other direction, add 2 thrusters. Okay, that makes sense why it changed that, why it gave us that result. So let's go ahead and change these math dot ceilings. I think it's just those 4. I don't think yeah, it would have to be just here. We'll change these to math dot floor, which means it rounds down in all cases. I think there's just a math dot round as well that'll, round it up if it's 0.5 or above, and round it down if it's 0.49999 or below. But we're going to set it up so that even if it's 0.9998, it's going to round down. Which I think is fine. I guess we're going to find out. Okay. Script has been deployed. Let's go back in here. Import our new script into our current ship. Excuse me. Oh, okay, yeah. It's got this weird behavior where, since I was scrolled down part way, I hit run. There were logs, but they were only up at the top. But it kept the view scrolled down, which is awkward. There weren't actually enough, there weren't enough instructions to warrant a scroll bar, so one didn't exist. But it also didn't automatically scroll me back up to the top. It's a little weird when it does that, but oh well. Okay. Check this out again. Most of this is the same. Distance to goal, almost 16. 1.7 seconds before, 1.7 seconds after. 10 steps, 10 steps, because it's rounded down. So total is 20. On the up-down axis, our distance is tiny. We say we require no thruster activations. On the right-left axis, same. No thruster activations required. So the top of our heap now looks like hold up, why are you doing all this again? Oh, because I do the heuristic evaluation as part of my logging. Oh, this is going to be a mess. Okay. That's fine. Here we go. Our H score, 3.4. So yeah, we're saying 3.4 seconds and 20 total thruster activations, which is much more accurate than the 26 that we were estimating before. Man, I need to cache this stuff so it's not spitting it out every time. This is going to be a mess, but alright, we're going to take a look at the next step. And our logs are too large so we can't even see the top. Alright. That's fine. Okay, I'm going to comment out these echoes we added in because they get printed out far too often. And we're going to see if the changes we made make any difference at all. Deploy the script. Script's been deployed. Refresh. Load it in. Go. Run. Run. 3.420. That looks good. All right. So this is our processing of that start node again. 3.420. So if we fire Thrust back. Good. Then we have a number that is very slightly higher than our earlier one, and still 20 thrusters. So yeah, that makes sense. Thrusting down makes it worse. Down and back. Man, our number's a little bit better, which is, it's fine. It's just awkward. Why is it better? Why is it better? Floating point math is why it's better. Floating point rounding errors. They should actually be exactly identical F-scores. Or, well, exactly identical time portions with a little bit worse thruster activations. It's supposed to be the tiebreaker that makes this one better. What if when I get to the three-way ones, right, down, and back? 340,509. I should have written this down. 40509. I think it's pretty much the same. 399,55715. So at least that one registered as worse than this one. It still registered as better than the one that should be best. I guess I kind of have to hope that it balances out in the end. Ugh. But, okay. Okay. Alright. I don't want to step through every node. I've looked through enough for it to show me that it at least looks more reasonable. We definitely fixed problems. Don't know if we fixed all the problems, but we definitely fixed problems. So I want to see what it does with a clean slate. So we're going to go back. We're going to swap this to do its normal run. So we're going to remove this. So it's allowed to do more than one instruction at a time. And then we're going to add back in the commands that instruct the script to run again on its next step. I think those were the only things that needed to change. I think that does it. Alright. Deploy. Well, that's deploying, which it has now done. Get rid of this ship. Give me a fresh script. Copy. Replace the blueprint. Replace the projector blueprint. Recompile the brain and say go. See what happens. Do it. Do it. Do it. I dare you. It's not doing it. Oh. Oh, I think it was doing something because my game just stuttered, which means my script's probably going nuts. So it's going, it's just not finding, a result in a timely fashion. Which could mean a lot of things. You know what's an easy thing to try? See if I can get a word in. the game's not super responsive when it's repeatedly running a script 60 times a second. Uh, but yeah, managed to recompile, pause the script. I'm gonna try just giving it a wider berth. I want to see if that makes a difference. I think this... Okay. So I had this issue before where the reason I tried that, what I was doing was I expanded the radius um, to which I would call a state acceptable. Consider it as having met the goal. I changed it from 1 meter to 3 meters. So if a state was within 1 meter of the goal, or up, now that it's updated, if the state was within, the location was within 3 meters of the goal, and actually since I'm using the same number, that the velocity the ship was at was within 3 meters per second of 0, so less than 3 meters per second, then we consider it good. Because I had a problem with that before because I'm only instructing the thrusters to run all or nothing, and I'm only running them once every 1/6 of a second. It's possible that, I'm just not capable of actually hitting that goal. Because it's too precise a target. So by expanding the radius, I thought maybe I'd hit it, because that was an issue before, where I was trying to be too precise, and like at 8 meters I could find a goal, but at 16 meters, just because of how fast the ship was going at that point, I couldn't quite land it. What also might be happening is that, we saw that when we fired the rear thruster, it was a good result. When we fired the rear thruster and I think the down thruster together, it actually registered as a slightly better result, which is not great, because that means we'd have to evaluate both of those states over and over again. Because if those are both valid, then when we look at where it went forward for just 1/6 of a second, just firing the rear thruster, from there, if we again just fire the rear thruster, or again fire the rear and down thrusters, those are also going to be very similar. And we may have to check both of them. And not only both of them, but continually check all of their children. Which is not great, and it gets out of hand. Like, it just gets to be so many states to evaluate. And I suspect that might be what's happening. Is that it may actually eventually find the answer, but it's having to look at so many possibilities that it's not getting there anytime soon. I guess there's one other thing that we can try that would make it faster, at least. That's pretty simple. Let's put this, actually, hell, let's leave that at 3. 3's fine. Let's drop this to 8 as a shorter distance to go. So there's a lot less room for expansion, constant expansion. It stopped. What do we think? Did it stop because it found an answer, or did it stop because something exploded? Give it like 50-50. It found an answer. And this answer looks totally reasonable. This answer looks completely reasonable. So it prints out the instructions that it follows in reverse, which is just because it's simpler to output. Honestly, I should change it. But yeah, what it's saying is fire the
That one's reversed. This one's normal. Fire the rear thrusters, 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 no thrusters. That's a little awkward that displays a blank, but it's fine. And then the front, 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 front for the last 4 ticks. Odd. Well, normally I would expect it's odd that it fired the rear thrusters so many more times. Well, 3 more times than it fired the front. The front. But I did allow it to say that the end goal, we were allowed to be off by up to 3 meters per second. 3 meters per second. So likely, we don't have to, like, this is going to get us there faster, because I told it that a valid goal state was ending at going 3 meters per second instead of 0. Meaning it did not have to slow down as much, so it might as well speed up more instead of slow down. So this actually makes perfect sense, and that's fantastic. That actually worked. So the longer distance is a problem I can solve. Let's watch it in action, because that would be such a fun way to just end this. I know it hasn't been that long, but let me do what I wanted to do. So I'm gonna edit this. So this is our template ship, so I hadn't updated anything. Let's put the goal epsilon back at 1 because I think it can succeed. But let's go to a forward goal of just 8 meters because that should work. Like, it was able to calculate it within accuracy of 3 meters and 3 meters per second, so hopefully it can also do 1 meter per second. We're going to find out, that's for sure. Copy it. Place the blueprint. Projector. Place the blueprint. Brain. Probably should recompile you because I don't remember what you were doing. Run. So it's not going to hit that goal, it's going to hit halfway in between. Should see it do its whole thing. Come on, do your whole thing. Do your whole thing. After the bar retreats. Calculates. No. No, you're not doing anything. Come on. You're making me look like a fool here. No. Okay, maybe I need to allow the terrible accuracy. Oh. Come on, ship. Come on, ship. Making me look like a fool. Alright. 8-3. We know that's supposed to be capable of finding a valid path. Oh. One more time. Build the ship. Alright. Yep. Computes. Accelerates. Slows down. Comes to a stop. And then it's told to go destroy itself. I should add a little pause in there. It worked. It worked. I know, all that just so it could... Don't turn my jetpack off. Actually, I can turn my jetpack off over here. There's no gravity, but... Although, now it's moving. Look at that. Look at that. It did it. Slowed almost to a stop. Yeah, let's give it a little bit better demo. Let's give a little bit better demo of this. So bear with me for a second while I add in new GPS coordinates. Oh, these are not overly precise. That's fine. That'll make it easier to do the math. So halfway in between these will be our 8 meter goal. So between -280 and -1880. Oh wait, that's just straight up 16. Is -1080. Okay, that's fine. Actually, why don't I just go here? get... This will be approximately where it is. A little off, but I'll just create a new from current position. Call it prox goal 8 meters. And then we'll update it. So it should be 10.80. And then y, halfway between 504 and 463. I need an adult with a calculator. 504 4.63 divided by 2. Negative 4.8. Well, 3.5. It'll probably correct itself to 4. That's fine. Okay. Oh. Oh no. Oh, I changed the wrong one. This was 4.63. 63. This one should be negative 4.835. Okay. And then halfway between 70.92 and 70.96 is 70.94. I can do that one. Cool. Okay. So that should be our approximate goal. Let's swap you back to here real quick. I will show off a little bit of the brain instructions. So what the brain does is it goes through a series of instructions. So it starts out by registering the welders. There's just the one welder out here. It's set up so it can handle multiple, partly because I handled multiple in some of my early tests, but that's not necessary for this kind of test. So it registers the welders, so it knows the IDs, it knows what it's communicating directly with. It tells the welders to reset if they're not reset so that they're ready to build. Commands it to build the ship that is currently in the projector block. Waits for the ship to be built, the welder to release, and then we register the ships so that we know the ID of the ship or ships we're communicating with. And in this case, the ship is going to change every time because we're building a brand new one. And then once the ships all acknowledge their registration, we have it plot a course, which sends that plot message. Once we have the courses, it logs out the path, tells the ship to run its instructions, and then once all the ships have run their instructions, it sends a command to the ship to self-destruct. So what if I just don't do that? Yeah, no, that's fine. That'll show it off a little cooler. And I can just edit that here. Edit. Yeah. Don't send the command to dispose of population. Bam. And go. So now, it should do everything from before, except the ship will never receive self-destruct. It will probably come to a stop somewhere past this point, partly because, well, I don't know, pretty close. Pretty close. Because it was still going faster when it reached its goal, but it was also considered to have reached the goal further back. Because we had a 3-meter radius. And yeah, I believe the target coordinates are actually the center of the remote control block, which is this one. So, like, it's definitely closer than 3 meters away. So thanks to the combination of being considered to have hit the goal within 3 meters and also being allowed to still be going 3 meters per second, meant that when we activated the inertial dampeners, once we reached that goal, we got pretty damn close. I call that a win. Clearly, the algorithm has still got some bumps to work out, considering it was struggling to find a correct route if we go much further than this. But I got my ship to come to a stop where I wanted it, even if where I wanted it was only 8 meters away from where it started. Maybe not super impressive, but it definitely works. And I think that is a wonderful note to end on. Um, yeah, I'm super happy that that works. The other stuff is tuning stuff that I can work out, and honestly, I also feel pretty okay. Like, well, we'll see. I'll try to do some of that off stream probably because I don't think it'll be very interesting to watch. But at the same time, I have found that I'm kind of productive at doing this while streaming, partly just because I can forcing myself to talk through it helps me notice things I might have missed otherwise, which is really useful and great. Um, so we'll see. I may try to do some of it off stream to make what I do stream more interesting, but I may just stream it for my own personal benefit, even if it's boring as hell to watch. So, but yeah, no, look at that. Look at that. Came to a stop. I got a ship to stop. All through the power of coding. But yeah, I'm totally fine with that. Like I said, I was good with the short stream tonight, and I did something fun. So, thanks for joining in. I hope you liked getting to see something actually happen. Unlike last stream, which was like 98% spent in Visual Studio, which maybe was fun to watch, but not for everybody, I'm sure. But yeah, this is great. I love having a thing to actually demo. So yeah, my goal from here will be to kind of refine this so that it can successfully and efficiently navigate to points further than 8 meters away. So I'll figure out what I need to tune to allow that to happen. I actually have a couple of thoughts on places to start already, but not going to get into that tonight. And once I get that into a fairly reasonable state, I think the next like kind of major milestone I want to add in is to try and add in gyroscopes. Right now we're staying on the grid, never twisting the ship. I am much less confident in exactly what gyroscopes are going to do to my math. And it's very possible that if I want to add in gyroscopes, I may actually need to look at a different kind of algorithm than A-star, which is great. I would love to learn something new and more efficient. It's just harder because A-star is something I already had some familiarity with, even if it was from several years ago in college. But yeah, adding gyroscopes just means, I mean, it ultimately means much simpler paths because the ship's just going to orient to the direction that it can travel. I would think the ship would orient to the direction it can travel fastest and just go in a straight line from there. Once I can navigate in a straight line with both thrusters and gyroscopes, then we'll look at avoiding obstacles. But it could be some time before that happens. But who knows? Honestly, like I said, I've progressed faster on stream than I do off stream. I think because of the talking through things, which is kind of great. Also kind of sucks. I'd like to be able to be efficient off stream too, but who knows. But talk your ears off enough without doing anything. I said I was going to be done like 5 minutes ago, so thank you for joining me. If you want to see more of, ships go farther, better, faster, harder, stronger, something like that, then yeah, come and join me in the future. Hope you had some fun. I certainly am. But yeah, I'm going to get some sleep. Hope you all have a great long rest, and I hope you recover all of your spell slots. Good night, everyone.